G'day and welcome back to RC Model Reviews, and yes, it's part 2 of the ZMR250 version 2 build. Yes, a part 2 video, I'm sorry to disappoint. This is the one that FPVModel.com sent me to build. It is the version 2. I've been through the basic specs of the thing before. I had a grizzle last time about this power distribution board, PDB. The problem was that obviously if you put the arms in the specified places, we're going to get shorting out on some of these lands here. And I wasn't happy about the very thin traces and a few other issues to do with this PDB. It was a pretty amateur layout. But to their credit, FPVModel sent me the version 1.2 version of the PDB, which is improved in some areas. Now, the areas where the arms go are free of any kind of copper traces, so there's no risk of shorting out. You don't have to use plastic washers and you don't have to use any kind of spacer between the arms and the carbon fibre. That's wonderful, it's brilliant. Doesn't solve all the problems. There are still a few things I don't like about this PDB. It'd be nice to see a version 2 that was designed even better than this, but we'll have to see what happens. This will work. I have built the unit using the PDB. Initially when I had this other one here, I was only going to use it to reticulate the power to the motors, and even then I thought, oh, why would you bother? But this one, I've reticulated the power to the ESCs through the board. The signal leads for the ESC connect to the board. The NAS32 is also wired into the board. I've done it a little bit differently to the way they had on the instructions. The camera the leads for the camera here are wired into the board, and the leads for power and signal that go to the video transmitter are also wired into the board. Now there's a few nice little touches here. For example, you can see that the leads for the video camera or video transmitter I should say, go onto these little copper pack tracks here, and there's actually place for a cable tie so that these are nicely stress relieved, so that these wires, moving these wires here isn't going to put a big strain on the parts where they connect to the circuit board. That's kind of nice, that's really good. Also there is obviously a cable tie at the back here to relieve the stress on the power leads, which is another good point. Now there are a few downsides to this PDB, things I don't like. Now you notice here where I've put the NAS board on, I've used a couple of servo connectors. They provide a couple of servo jumper leads, and I just cut one in half and soldered it to these bits down here, connecting it to the NAS board. It's a real simple solution. For example, one of the servo connectors goes crossways like this, so that handles the signal connections for motors 3 through 4 as marked on this little board down here. The other one goes vertically, and that is supposed to handle the power, the negative, and motor 1 connection, because if you look on the board here, you can see those things all clearly noted or clearly labelled on the circuit board down here. We've got, hold on, I have to get my glasses for this. I'm getting old. Oh, I hate getting old. We've got ground, we've got BEC, we've got motor 1, motor 2, motor 3, motor 4. So having these two leads here was a great way to easily connect up to the NAS board, and I've just put pin headers on the NAS board as you would normally expect to do. The thing I didn't count on, which is a little bit unfortunate, and again where this PDB could be improved, where it had BEC down here, has the word BEC, I thought that'll be 5 volts that I can use to power the NAS board. Brilliant, because hey look, we've got a 5 volt BEC on this board, right? Unfortunately, that's not the way it's wired. The PDB doesn't actually take the 5 volt BEC and run it over to this connection here labelled BEC. That BEC connection actually simply appears over here. If you've got an ESC with a BEC in it, you can connect the positive wire from the ESC to there, and that will power the NAS board. But hang on. Why would you use the ESCs to power the NAS board when it's got a BEC on board? Why would you bother not using that? So this board seems to be a little bit confusing. Why would you even bother having a connection for the BECs out of the ESCs? Makes no sense. So as a result, having already strapped down the wires to my video transmitter here, I have to now run a wire, because I can't run a wire from these pins without farting around too much. I have to run a wire from the 5 volt source over here all the way to this land over here, which is labelled BEC, and then it will go all the way back through the PDB to here to the NAS board. Very torturous, and what I would recommend is that there's a little, they just dispense completely with this BEC pad over here, because it's not needed, absolutely not needed, and simply run the 5 volt BEC power to this pin here, or put a jumper in so you can choose either. But why would you not use the onboard BEC if there is one? I see no reason not to. So yeah, the designer of the power board really still has got a bit of work to do to bring it up to scratch. Nevertheless, moving on, you can see that the ESCs fit nicely on the arms. I've used cable tie and 3M double-sided sticky, and I've left the leads a bit long on these motors and ESCs because I may want to put these on another quad at some stage in the future. Just gives me a bit of leeway, because when I'm building frames, a lot of people send me frames, but I've got to fork out for 4 motors, 4 ESCs, an NAS board, camera, video transmitter, flight controller. So it soon adds up. The frames are the cheapest bit. So I may need to reuse these at some other stage. For example, if FPVModel sends me another frame without any motors, I'll have to whip these off or whip the ESCs off. So there you go, that's why I've left those longer. Now, having said that, there are a couple of other issues I think they could improve things on. You'll notice that here, the standoffs, the vertical columns, attached to the PDB. And I've already mentioned my concerns about the very thin copper traces on the PDB. The fact that those really thin copper traces could be damaged in the event of stress on the board. And if I can hold this up to the light properly, I'll give an example of those thin copper traces. I mean, here's one here. See how thin that is? Very, very thin copper trace. So if this board is flexed because we've got a standoff here or wherever, causing stress on it, it could crack that fine copper trace. So why didn't they do the obvious logical thing? To get around that problem, use longer bolts and a simple 4mm spacer in here. So put a 4mm spacer, a 4mm longer bolt, and then the carbon frame on the bottom would take a great deal of the stress, relieving the power distribution board of the stress that's obviously going to suffer when you have the thing built like that. Simple thing. I know, I think it's Thug Frames or someone like that produces a kit which includes longer bolts and spacers. So why not integrate it into the design of the version 2? It's such an obvious, it's a no-brainer. It's a shame they didn't do it, but hey, maybe they'll do it with the next version, who knows. Up front here we've got obviously the little pads for the camera. There doesn't seem to be a cable tie point here, which is a shame because you know, everything that you solder to a board, you should have stress release. I'll have to put some hot glue on here. Otherwise, especially these seem to be very stiff wires, so they'll fracture where it solders onto those pads. They're guaranteed with vibration and a few crashes. You'll end up with one of these wires fracturing off the little copper lands there. So I have to put some hot glue. Always do that. Always put some hot glue on that. It's absolutely essential now. Everything else looks pretty honky-dory, got to say, no problems. I didn't pot this with epoxy because I'm testing it as it came. I'm not going to modify it, we'll need to know what happens. We've got the camera board goes in the front. Now I've made a change to the camera board. One of the things that I noticed with the camera board when it came was it came with mounting screws, but there was no spacers involved. So all you got was some screws about yay long, and if you bolt the camera straight to the carbon fibre camera mount board there, you're going to have some problems because it's going to short out. All those little bits of metal, the conductors on the front here will short against the carbon if you try and snug that board there up tight against the frame. Also, as you can see in this video, the camera will be proud of the front of the craft. In fact, even with the bolts they provided extended to maximum, so I put some fuel tubing over the bolts to give me maximum spacing between the camera plate and the camera board itself. The front of the camera still poked out beyond the end of the mini quad, so if you smack straight into a tree or a wall, there goes your camera, it's toast. To get around that, I thought, oh, well, I'll just use some of these nylon spacers that I have already. And also the problem with just bolting the camera straight to the frame is that or to the mounting plate, is you don't get any angle on it. And I wanted some angle on my camera because obviously when you're flying along, you want the camera to be angled slightly up. So I did this arrangement with longer spacers on the, what is it? Which way does it go? Let's have a look now. I think it has to go this way. Crystal to the top. There you go. Longer spacers on the top and shorter spacers on the bottom, which gives the camera a bit of an upward facing angle when that plate is vertical, as you can see there. That's great because as you tilt forward to fly forward, you'll still be able to see the horizon. There's not much tilt on this. I'm going to give this to someone who's learning to fly mini quads and they hopefully will have a ball with it. So I'm not going to have too much camera angle on it. Now, I thought that's great. So as you can see, I'll put nylon spacers on. Also, these nylon spacers bring the lens of the camera back behind the, I'm going to try and do it here, behind the frame, as you can see. So there you go. That, if this hits straight into a concrete wall or a tree, the camera lens is protected by the overhang of the frame top and bottom. And I thought, hey, that's a brilliant idea. That's what I've done on all my other ZMR250 builds. It's a great way to protect the camera. But the problem is, unfortunately, the power board again lets us down a little bit. If we look down here, you can see that if I was to try and mount the camera like this, then the corner of the camera board there is actually going to touch on that copper, on that positive wire there, because these copper lands come too far forward. And so I can't use this strategy after I've gone to all the trouble of doing it. If I was to try and mount my camera with those spacers as they are, bringing the camera nicely back, a bit hard to get in the hole there, bringing the camera nicely back so it's protected from impacts, then on this side it's going to impinge on that pad. If I turn it around, you'll see on the other side, same thing happens. And the problem is that along the edge on the corner of these cameras here, that little copper there, it's negative and it's going to touch on the positive pad. So if we bolted it all down and plugged it in, the magic smoke would come out in gushes. It'd be huge clouds of magic smoke and nothing would work anymore. So camera mounting is a disappointment with this particular PDB. I don't know what I'm going to do to get around that. I'll just have to have the camera poking out, go back to the original arrangement with the fuel tubing and the bolts and have the camera poking out the front. And yeah, actually when it's going to someone who's beginning, it's not such a good idea. Perhaps what they could do with these mounts here on the next revision of the board is move them further inwards and back a bit, because there's enough room to do that. They can move them in and back over here, reposition the signal wire somewhere else, but move these in and back. Or alternately, they could even go as far as repositioning them. I mean, we've got this positive pad here we're not using. We could put a negative pad alongside it and position it well out of the way over here so that this area is left completely free for the back of your camera. We're thinking about FPVModel. Have a go at that, see how you get on. Now the camera itself is a bit of a pleasant surprise. This is a pretty low cost camera, but it does seem to have good wide dynamic range, good resolution, good colour. So at least on the bench, I've tried it on the bench, pointed it at the overhead lights, and it seems to work really well. In fact, I'd say it works at least on the bench, as good as the 600 TV line Sony camera, and this is actually cheaper than that. So one thing I didn't like, the crystal was floating around in mid-air, so as you can see, I put some hot glue on there to hold that down, because otherwise those wires would just fracture and your camera will stop at the most inopportune moment. I'm going to obviously give this a really good thrashing out there in the real world, and we'll see how it produces results when it's tasked with lots of movement and the various contrasts and lighting you get when you're flying a mini quad. And also test for latency. Haven't done that yet. I don't think latency should be too much of an issue, because it's a pretty basic board camera. It's only when you start getting really intensive image processing that latency starts to creep up on you, but I will test that. So yeah, I'm going to have to go back to the mounting board, back to the drawing board to mount this camera again, unfortunately, and then the quad itself will be done. Although one thing I wasn't too fussed on was the quality of milling of this actual top frame here. The camera board would not fit in these slots. These slots were too narrow to take the camera board, so I had to file them a little bit to open them up. It's a little thing, but gosh, you think they could just use a better CAD or a better numeric code file for the routing so that it did the job properly. I hate having to fettle stuff that's supposed to be, you know, take it out of the box and put it together. There we go, that'll go on there, piece of cake, no worries. As I said, there's only 4 of these little bungs, so I'll have to put zip ties through there so I don't lose any. Pretty standard as far as ZMR250s go in that respect. Now the video transmitter, obviously, I have the wires here. I'm going to mount it underneath at the back. That aerial, no, we're not going to use that. I've used it for testing, and this actually got quite hot, and I was a bit concerned that it actually stopped working at one stage. So this antenna is, as I suggested, utter crap. And I will make up one specially for the job. And then we'll get on and we'll take this out and we will fly the snot out of it. But there's part 2. That's the building. That's what I did with it. That's how it looks. And I've got to say, this is overall absolutely the most tidy ZMR250 build I have ever made. And all my complaints aside, the PDB does a pretty serviceable job of allowing you to hook everything together. And certainly for a first-time builder, it's going to be probably an awful lot easier than actually messing around with the wires and doing it themselves. So there you go. I have to give it probably at this stage a 4 out of 5 for this frame as it goes so far. And next, of course, flight tests, we'll bang it into some stuff. We'll throw it around and see if it handles very well, see how the motors hold up, see how the ESCs hold up. And that'll be part 3, so stay tuned. If you've got questions, comments, all the usual things, put them in the space provided under the description of this video, and I'll do my best to answer them or address them. In the meantime, thank you for watching. I'll get this finished, get out and do some flying. Bye for now.